Welcome you all friends. I am Professor Mohammad Tariq, Department of Economics, AMU Aligarh. In the last class, we talked about Markowitz model. Actually, this Markowitz model is related to the determination of minimum variance portfolio. The determination of minimum variance portfolio. Under this, we try to minimize this variance of portfolio, variance covariance of the portfolio subject to the two constraints, and we had taken the help of this Lagrange multiplier with the mathematical tool of maxima and minima. Maxima or minima, the condition where the first order derivative it should be equal to 0 with respect to the respective variable, and we reached at n plus 2 equations. Now these n plus 2 equations we will again be writing down today. The equations that we reached after minimization of the equations that we reached after minimization of function sigma wi wj sigma ij, this minimization of this function, we obtained these equations, the equations where sigma ij wj j is equal to 1 to n minus lambda r I bar minus mu is equal to 0. Sigma wi ri, this is equal to r bar, and sigma wi is equal to 1. So this we have achieved, and it is on the basis of this we had n equations over here. I is equal to 1, 2, 3 up to n. So we have n equations over here and 2 equations, this and this. So in total n plus 2 equations are there, n plus 2 unknowns are there. The relationship is linear, so we can get a unique solution for the values, and it is on the basis of this that we are in a position to find out the portfolio in making investment in an assets. So by using this equation, this final derivation of Markowitz model, now we'll be explaining two theorems. One is known as Two-Fund Theorem. Two-Fund Theorem, and another one is known as One-Fund Theorem. So let us talk about this Two-Fund Theorem. What is this Two-Fund Theorem? What is this Two-Fund Theorem? First we will take up this, then after this we will take up this One-Fund Theorem. What is this Two-Fund Theorem? The Two-Fund Theorem, this states two efficient funds or portfolios can be created by taking into consideration mean and variance considering mean and variance as well as the covariance, which we use the term covariance as well, mean and variance considering, and all efficient investors by efficient investors we mean that investors who are willing to invest in efficient funds, efficient portfolios, need invest in combination of these two funds. So what we can generalize that two mutual funds can provide a solution. Two mutual funds can provide a solution to investment services for everyone. Mutual fund, actually these are the investment in diversity of stocks by the agents. So by mutual fund we do not mean that investment in any one fund or something like this. It's a diversity of funds done by the agents where the individual saves and they make investment into this, and that is being invested into a diversity of funds. So if two mutual funds are there, they provide a solution to the investment services for everyone. This is the crux of this two-fund theorem. The two-fund theorem can provide the maximum return as well as the minimum variance to this investors. Clear? But this two-fund theorem, this is based on this certain assumption. This is based on certain assumptions. What is that assumption? That the decision by everyone is being taken. Decision by everyone is being taken on the basis of mean rate of return, the variance and covariance of the funds. Number one. Number two, the second assumption is this, that thinking of each and every one, or the assessment about the fund by everyone is same, in the similar fashion. Everyone is same. This assumption is very difficult to digest, that okay, the decision is being taken by mean variance and covariance, it's all right, but everyone will be thinking in the same fashion, in the same way, the assessment by each and everyone will be same. This is very difficult to digest. But suppose as an individual investor, I do not have time, or I do not have this inclination, or do not have an acumen regarding the assessment of the portfolios, assessment of the funds. Then in that situation, what option is left with me? The option left with me is, as an individual investor, the option left with me is nothing but to rely on those who are experts on this, or to rely on those on whose assessment we can trust. So the assessment by others who are experts in this field, and in whom we have a trust, that I'll be relying on that and making investment into the portfolio which is being decided by them, the two portfolios. Clear? The calculation for this on the basis of the results that we had obtained from this Markowitz theorem, it can be done. What was this? Again, rewriting the final conclusion that we had obtained to the Markowitz theorem. This was Wij sigma j is equal to 1 to n minus lambda ri bar minus mu is equal to 0 sigma wi ri is equal to r bar and sigma wi is equal to 1. This was this, I is equal to 1 to n. Clear? Now we try to find a solution for all values of r bar. We try to find out. We take two extreme situations with two extreme cases. Number one, when lambda is equal to 0 and mu is equal to 1. And number two, when lambda is equal to 1 and mu is equal to 0, that is being taken. And we get the values, solution to find the values for lambda and mu. And the solution to find the values of lambda and mu, once we get this two extreme situation, the assets are being decided. Assets are being decided in between these two values, in between these two extreme values, and we get a combination of, combination of two assets. We get combination of two assets in this. So this is the crux of two-fund theory, where the two funds are being treated on the basis of minimization of the variance, and the decisions are being taken not only on the variance covariance but also on the mean rate of return. The result that we obtain this from the Markowitz theorem, this provides a path towards the decision of two-fund theory. Now there is another theory which is one-fund theory. One-fund theorem. What is this one-fund theorem? Before coming to this statement of the one-fund theorem, this is actually based on when investment is being done into one asset, one risky asset, and one risk-free asset. The risk-free asset, you can say this is a sort of interest-bearing asset, where the rate of return is fixed. Normally, when we make a portfolio, the portfolio is being made where some risky assets are there, some risk-free assets are there, so that borrowing and lending could be allowed, just to allow borrowing and So the borrowing and lending could be allowed into this. So what is a risk-free asset? For risk-free asset is an asset, risk-free asset is an asset where sigma is equal to 0, technically speaking, where variability in the asset, this is equal to 0. The return is there, interest bearing asset is there, the return is there, but for this the variance is equal to 0. This is number one. Now suppose we have if borrowing is taking or lending and borrowing, if lending is taking place under this interest bearing asset, borrowing and lending, if lending is taking place, lending means purchase of bonds, lending means purchase of bonds. If lending is taking place, then in this situation we have the positive weights with the assets. We have positive weights for the asset, and if borrowing is there, means sale of bonds taking place, then the weights assigned to the asset is negative weights. Are being assigned. Clear? So when we add make a combination of one risky asset with one risk-free assets, this introduces a mathematical degeneracy. It introduces in the calculation process when one risky asset plus one risk-free asset, then this introduces this leads to a sort of mathematical degeneracy, and this mathematical degeneracy actually simplifies the shape of efficient frontier. This simplifies the shape of efficient frontier. So let us try to understand this with the help of example. Suppose we have an asset which is risky and the rate of return is R on risky asset rate of returns are R, which is with the mean rate of return on all such assets, R bar and standard variance, mean rate of return and variance sigma square. There is another RF risk-free asset. RF is your risk-free asset, and here what will be the value? Sigma will be equal to 0. So these two assets, risky asset and risk-free assets, if we talk about the covariance between R and RF, this will be equal to expected value of R minus R bar, RF minus RF, mean of this will be, because it's a fixed asset, so mean value will be the same. So what is this? This will be equal to 0. The covariance between these two will be equal to 0. and the mean rate of return between these two assets. Suppose the asset is the risky asset, mean rate of return of the two assets. If the two assets are being purchased with weight alpha and 1 minus alpha, the alpha is for, the weight is for this risk free asset, and 1 minus alpha is the weight for, this is the weight for risky asset. So the mean rate of return on the two assets this can be written as plus 1 minus alpha into R bar. And what about the variance or the standard deviation? Standard deviation of return, as sigma in this case is equal to 0. So this will be equal to 1 minus alpha square sigma square, which is equal to 1 minus alpha into sigma. Why? Sigma is 0 for risk-free asset. Now, for the time being, if we consider then the equation, we do not write it down, rather we write down the general form of the standard deviation. So, the general form of a standard deviation will be alpha into sigma f plus 1 minus alpha into sigma. The sigma f is equal to 0, but I am writing it down, some purpose is there. Now, if you look into this standard deviation of return and this mean, what do you find? Both mean as well as a standard deviation, they both are mean and standard deviation, they both are linear in alpha. They both are linear in alpha. Clear? So, as alpha varies, and what about the value of alpha? The value of alpha will be in between 0 to 1. So, as alpha varies, the point representing the portfolio, how much will be invested in risky assets and how much will be invested in risk-free asset, the point representing the portfolio, the point representing the portfolio, it traces out a straight line in R sigma plane. It traces out a straight line in R sigma plane. Clear? So, it traces out a straight line in R sigma plane. Now, suppose we have n assets. We have, suppose we have n risky assets. Suppose we have n risky assets with mean rate of return Ri bar clear, and the variance is covariance sigma I j, and there is a risk-free asset, with the return, fixed rate of return RF, and the variance here, this will be equal to 0. Clear? So this will have, when we make a combination of these, I told you earlier that this will have a profound effect on in the determination of shape of feasible region, in the determination of shape of feasible region, determination of shape of feasible region. So how this feasible region, definitely this feasible region we determine in this R bar and sigma plane. Let us try to explain this with the help of a diagram. So we have this feasible region, we have already derived this feasible region. I am deriving, sorry. So this feasible region, so different assets are there in this feasible region. This is the dark shade. This is the dark shade. So now profound effect on the shape of the feasible region. The shape of the feasible region, when we have all the n risky assets are there, the feasible region is this, that we have already determined earlier. Now suppose we make a combination of this risky asset with one risk-free asset. So the risk-free asset, this means, what is this for risk-free asset? The sigma is equal to, risk-free asset sigma is equal to 0. So the asset will be determined within this feasible region. With this feasible region, all the assets will be the risky assets. Now if we combine this with the risk-free asset, this will originate an infinite line originating from this point, this axis. Along this axis, whatsoever point you may take, this, and on all these points on the vertical axis, what do you find? Sigma is equal to 0. So the assets with return, certain amount of return, suppose R1 fixed amount, R2 fixed amount, R3 fixed amount, all these are risk-free asset along the vertical line. So you can have infinite line passing through this, and all these must cross within this dark shades, so like the maximum, and it will go indefinitely. So it might go like this, and it might go like this, and you get a triangle like this. Or might get a triangle like this, the light shaded triangle like this, which will give you the totality from a triangular shape feasible region. So this is, so risk-free asset triangular, what is this? Along this line sigma is equal to 0. So risk-free feasible region, so your risk-free feasible region will be decided by this light shaded triangular light shaded triangular region. So this is risk free feasible region. So now it is on the basis of this that we are in a position to now to write down the statement of one-fund theory. So what is the basic concept of one-fund theory? That investment is being made in one risky asset and another risk-free asset or interest-bearing asset. That is normally being done by the investors to allow borrowing and lending freely, risk freely. And what is the basic difference? Let me repeat once again between the risky asset and risk free asset. For risk free asset, your variance or standard deviation is equal to 0. For risky asset, your standard deviation is positive. So this is now what is the statement for this one fund theory. The statement for this one fund theory is there is a single here if you get this at this point where it is tangent, let this be f. So here you have a combination of at this point if you have a combination of risky asset as well as risk free asset at point f. Point f, you have combination of risky asset plus risk-free asset. This is the line which is originating for the risk-free asset originating from this axis where sigma is equal to 0. So what is this statement? There is a single fund, there is a single fund that is F in the diagram of risky assets of such that any efficient portfolio can be constructed any such portfolio can be constructed as a combination of fund F and the risk-free asset. This is what is here in this diagram at point F. The risky asset is there. The combination of risky asset with a risk-free asset, which is line originating from this point. So this is all about two-fund and one-fund theory. And this two-fund and one-fund theory, actually this is being derived, the basic concept goes back to the background of this two-fund or one-fund theory goes back to the Markowitz theorem.